started then. My name is Casey Frederick. I am a principal consultant with NavLabs, and I am joined by the incredible Haley Finegan, who you may have guessed is also a principal consultant with NavLabs. And we're here today to talk to you about activity chaining. To me, I believe activity chaining is beautiful, right? It's elegant, it's simple, it does what it needs to do. The user can quickly move from step A of their task to step B to step C. It's really snappy, really responsive. It feels good to use and move through that process, right? But I think we've all also been on the other side of that, right? Where we're a user or we're talking to one of our users who is on step A, then step B, and then step C, and when they go to click step D, all of a sudden they're kicked out of their task, right? They find themselves back on their task list. They're confused. Where did my work go, right? Do I have to do that again? Maybe even a little bit annoyed, right? And the last thing that any of us want is an annoyed user, right? So activity chaining. You go to look for it, right? You go to figure out what happened. You're looking through the logs, right? You're scrolling. There's not too much information, or you're looking through your process models, and you're having trouble finding what went wrong, right? Activity chaining is beautiful, and it's simple, and it's elegant. But when it breaks, it can break in silent, oftentimes subtle ways that can be really frustrating to figure out. So today we're going to be talking about the beauty of activity chaining, right? What's going on under the hood, what's happening, the hidden resource cost, right? As well as going through some examples of what happens when your activity chaining goes wrong. So walking through the session roadmap today, we've broken this up into 7 distinct groups. Step 1 is going to be the engine under the hood. So what's actually happening when your chain runs in the background, right? Step 2 is to chain or not to chain. That is the question, right? We're going to be talking through some common use cases of activity chaining, some places you might want to avoid it. Step 3, the hidden resource cost, right? So some things your architect might have skipped over, right? Step 4, complex subprocess patterns. So how do we go from the parent level to the subprocess and back up to the parent level and maintain that chain the whole way, keep it all together. Step 5, or section 5, race conditions and write then refresh, talking about stale data and how to prevent it. That'll be the end of me. You can be done with me, and you'll go to Haley for part 6 and 7. Part 6 is going to be troubleshooting broken chains, during which we're going to talk about reading logs and understanding limits. And finally, part 7, the most exciting part, the demo. We're going to be talking about seeing some actual examples of process chains, both working and not working, and talk about how to fix them. So moving on to part 1, which, as I said, is going to be the engine under the hood. So developers know what activity chaining does, right? From the user perspective, it's smooth, seamless, and responsive. Keeps everything together. The data flows nicely from step 1 to step 2, as we talked about earlier. But there are 3 main things that are also happening at the same time that are invisible to the user that they might not know is happening. At least I can say I didn't for a very long time. So what are those 3 things? So the first thing is that the execution priority is raised to the maximum, right? So we'll talk a little bit later about how different stuff is prioritized in the Appian engine, but you need to know for now that activity chain stuff goes to the very top of the list. It says, this is the most important thing to me, do this now, please. Number 2, it holds open a synchronous process thread. It's actively waiting. Think about it like a telephone. We're both waiting for each other to talk to each other to go and do the next thing. And then number 3 is it keeps the form in a loading state. So it basically says, okay, as long as I'm activity chaining, do not go to the next form until everything else on that chain has run, right? So let's talk a little bit more about each of those. So max priority. Like I talked about, chain nodes jump to the very top of the queue, right? They bypass your script tasks, your API calls, any of your unattended nodes, right? And they become the very most important thing. It's what makes it snappy. It's what allows the interfaces to load really quickly, is because we're saying this is more important than everything else. Please go ahead and do this now. But that priority doesn't just come from nowhere, right? We can't just pull new threads and more execution, power out of thin air, although that would be nice, right? It's coming from somewhere. It's borrowed, right? So there's a finite pool of threads which are being pulled from, which activity chains use in order to keep everything snappy and fresh, right? So since that's being borrowed, we have to be really intentional about how much we're activity chaining because we're taking it from somewhere else to divert its power to activity chaining. Number two, the same engine thread, right? So we're talking about synchronous processes. We're saying that, okay, all the execution context is maintained on the same thread, which is to say all of the, the variables and the information and the data are all passed between each elements on that chain and kept together in one singular thread, right? So they're kept together in order to be used together or displayed or acted upon, right? So it's we'll talk about this a little bit more when we talk about subprocesses and synchronous versus asynchronous and how they relate to activity chaining. One thing I also want to mention that we'll get into more with Haley is we're talking about taking threads from other places, right, for the activity chaining to use. And that doesn't just come from nowhere. Other stuff can slow down. It's important to point out that there is a 10-minute limit between attended nodes in a process model, right, for activity chaining. And if it goes longer than that, it'll break. There's no warning and no error. It's typically pretty silent. And you might say to yourself, Casey, my process is complete in 2 minutes. It's not a big deal. I'm never going to hit 10. I too was once like you until I hit 10, right? You have an API that in like dev or test is fast and responsive, but all of a sudden it's in prod and you're pulling back 20,000 records, and all of a sudden, we've got 10 minutes on our hands, and now the activity chain's breaking, and we don't know what's going on, right? So a lot of small stuff can add up and surprise you in ways you don't expect, and it's really easy to get to that 10-minute limit if you're not careful. So let's talk a little bit more about to chain or not to chain. We've got three main cases we're going to talk about today for chaining, although I'm sure there's a lot more we could all come up with. But the first one here is going to be, well, actually first, before I get into these, I do want to say activity chaining is awesome, right? It's really cool, really fun, I think. Maybe I'm weird like that, right? But it is not the default, all right? I think when I first learned, I learned that activity chaining was just like, this is what you should do. You should activity chain to keep all the data together. And I was throwing activity chains on anything and everything. But activity chaining is not the default. It's a deliberate architecture choice that has resource implications, right? So we have to be really mindful about when we're using it. And these are three such instances that we're going to get into now. So the first one is a wizard, right? There's no robot magic hat, but we're talking about a multi-step user interface, right? So like we talked about in the beginning, going from step A to step B to step C. And we want to have data that's preserved between all of those pages. So one of the common instances, right, is a file upload. So let's just say on step 1, they upload a file, and then they want it to be displayed on the summary page on step D or what have you, right? If we don't activity chain between those nodes, that data is getting written in the background, and we won't be able to pull in the file upload or whatever our data to the final screen. So it's really important that we chain through every step of the wizard in order to keep our data together, keep it all in sync and displayed when we need it, right? Otherwise, some stuff might look like it's missing. Number 2 is the write then refresh paradigm, right? This is something that we see with record actions and sites, which is basically to say every single modern Appian application. So if we're in a record and we click, in the top right, edit record, and we update some data, right? If we don't chain through that process, the form loads right away. There's a race condition, right? So the form loads right away, and our new data is not brought back. It's not displayed. This can lead to some questions from the user, like why is my data not updating? And just saying, just give it a hard refresh isn't really an acceptable answer, right? So we have to make sure that we chain through that in order to keep the data and stop the page from reloading until that activity chain has been completed and those data writes have occurred. And the last one is control of the A-bang start process response. This is the one that is kind of tricky for me. Let's just say that we have a button that calls an A-bang start process, right? So we start the process in the background, and then there's a calculation or something happening, and we want to get the result of that via the onSuccess parameter. If you don't chain through that process, the onSuccess will be null. The parameters are just brought back null. It just, you don't get what you need from the process. So we have to make sure that we chain through everything that we need before we release the chain and have the onSuccess callback occur and get the relevant data for us, right? All right, so talking next about the hidden resource cost. So this is what your architects might not have told you. No shame to architects in here. I owe my life to you. You've helped me many, many times. So the hidden resource cost. So let's talk about this, right? So we talked a little bit earlier about the priority queue or the execution engine. It's nicely split into three main parts, which are the chain nodes, which gets the lion's share of the engine threads, so it's the number one thing, right? Number two, which is the direct user actions. Think about it like your user forms, attended tasks, which might be unchained, and then number three is your script task, your smart services, anything else that's left that can be done in the background. So remember that every single chain that you run is consuming resource threads, right? It comes from a shared pool that all of these three are pulling from. In low traffic environments, it's basically invisible, right? If you've got an environment that has 5 users and very simple processes, you're never really going to be taking enough that it's going to be discernible. And that's the way that many of us learn when we're first starting out. So we're not really thinking about the performance impacts of this. But then all of a sudden, you've got a few years under your belt. You're in a large production environment that might have 1,000 active users and is doing like a lot of heavy reads and writes. All of a sudden, this stuff all matters, right? At scale, it's really, really important. And you'll have well-intentioned devs that are just activity chaining to keep things smooth and snappy, but at the end of the day, it's actually taking from your performance, your execution elsewhere. So it's really important that we remember that everything that we do, we have to think about what's it going to be like at scale. So the rule of thumb is to chain only to the last node that the user needs. So for instance, chain to like the last user input form or something, and then if there's some writes that have to happen after that, we can release the chain, we can let it go, because that's taking from stuff elsewhere. Talking a little bit more about complex subprocess patterns. So we talked about this a little bit earlier when we were talking about synchronous threads, but let's kind of get a little bit more granular before Haley takes you even more granular still. So when it comes to subprocesses, there's 4 things that have to happen in order to chain into a subprocess and then back out. And up here you can see a very simple example where we have a parent attended task where we're chaining. We have a subprocess node which we're running synchronously, which we are also chaining in, and we then pass the chain back up to the parent. So it's a 3-step process, right? But in order to do that, there are 4 things, that we have to be cognizant of. The first thing is that subprocesses must be synchronous, right? They're kept on a synchronous chain, and if we leave them asynchronous, by definition, it's fire and forget, right? So if I chain it into something that's asynchronous, I'm wasting my time, right? I'm wasting valuable, engine resources because it won't ever get passed back out to the parent, because an asynchronous process is basically just set it and forget it, right? So to chain into and out of a subprocess, it has to be synchronous. Number 2 is we have to make sure that there's a little checkbox on the process form, right, or the start subprocess node that says enable activity chaining into all initial nodes. We have to make sure this is selected in order to chain into that subprocess, otherwise the chain will break. Now, when we're doing this, it's really important for us to remember that 50 node limit, which Haley's going to talk about a lot coming up. We always hear, okay, there can only be 50 nodes between 2 attended tasks, right? It's not a quick cheat that we can do and have 49 nodes in our parent process and 49 in our subprocess and think, I'm all good, they're all under 50. It doesn't work that way, right? It's all counted in total. So that's 98, you're well above your 50 limit, right? So we have to make sure that we're really, really cognizant of that. We have to make sure that we configure chaining on all flows inside the subprocess to chain back to the parent. This even includes between the start node and the end node, right? Or the start node to the first script task or what have you. Those count. The start and the end nodes count for activity chaining, right? That's not free real estate. All processes launched via subprocess run the same execution engine as the parent. So really helpful to remember that. Last thing I'm going to talk about before I go ahead and pass you off to Haley is race conditions and write then refresh, which we talked about a little bit earlier, but let's just get a little bit more granular. So we talked about a user who's trying to edit a record, right? Without chain, the user clicks on the record action, they submit the action, and the UI immediately refreshes. That's really cool and nice of it to do that, right? Because it's trying to be really responsive. But the write is still in progress in the back end. So they're shown their stale data because there's a race condition happening and the data hasn't been written yet. And this is when you run into situations where users are confused. Why is my data not here? Do I have to refresh the page, et cetera, right? But with chaining, when the user clicks the record action, we use the chain to hold the thread open to chain through the write node, right? And when that's done, then we say to Appian, okay, now the page can reload, go ahead. So just a quick overview before I hand it over to Haley. Mitigating race conditions in general. So let's just say record action updates record data. If we don't do that, you're going to get stale data. So we make sure that we have the write then refresh chain to hold open the context before we write. You'll see the same thing with the start process, right? By making sure that we do not return the onSuccess call until we've gotten what we need via chaining. And finally, the multi-step wizard. We have to make sure that we are not loading to the next page without writing the first information. So really activity chaining at its heart is making sure that things only happen when we want them to. We only move to the next page when we want. And that's a really powerful, awesome part of activity chaining. So without further ado, I'm going to go and pass it over to Haley, who is going to take it over from troubleshooting broken chains.
Great job. Thank you, Casey. Yeah. Thank you. All right, now let's talk about when things go wrong. Chains break, sometimes by design, but sometimes not. And the skill of a senior developer is to know the difference and know where to look. Now, there are two failure modes for activity chaining. The 50 node limit, I think this is the first thing that we learn when we learn about activity chaining, is that the maximum number of unattended nodes that you can activity chain between two attended tasks is 50. Some other important things to note when we're trying to decide what counts towards that 50 node budget is that when we're activity chaining through subprocesses, all nodes count within the subprocess. So the start node, the end node, and everything in between count towards that 50 node budget, as well as that subprocess node and that parent process itself. So all of those nodes count. That's especially important when you have these long-running processes and you have multiple subprocesses to keep things organized and activity chained through. Something else to note about activity chaining when you're butting up against that budget, if you use MNI and you're activity chaining through an MNI node, every instance that the MNI generates counts towards your 50 node budget. So if you have 10 instances of a send email node that you've MNI'd over, that's minus 10 to your activity chain budget. Something else to note about the 50 node limit is that this is actually customizable in your custom.properties file. So whether you're on-prem or in the cloud, you can have the appropriate Appian support team go and update that value for you. Now this is a last resort. You don't want to have this as your first fix for if you have a really long process and you're like, oh, maybe if I just bump that up, I just asked my admin and they're going to ask someone else to go bump this up. It should be pretty easy. But this is a platform-wide change that you want to be very mindful of and careful of, that if you do decide to change it, that you've thought through every possible scenario before that to ensure that if you really need it, that this, again, is the last resort. And then finally, activity chaining errors can be found in the process execution logs. We'll be tracing those in the live demo and kind of showing you how to trace them from monitoring all the way to the process execution logs. And then some fixes that we recommend to you guys to help mitigate the risk of hitting that 50 node limit is adding an intermediary attended task, like a click to continue to reset that 50 node limit, or using a script task to do all the looping functions instead of using chained nodes within your process model and doing all that looping in a script task with a looping function, or merging like nodes. For example, if you have 5 write to record nodes, maybe instead use a single write to multiple record node instead there. And that will help mitigate the risk of hitting that 50 node limit. The second failure mode is the 10-minute timeout. So if an attended task is not reached within 10 minutes of starting that activity chain, the chain will break. silently. So this is most common in processes with API calls or really heavy database operations or complex subprocess logic that may take a really long time to load. And if we've decided to activity chain through that, then there's the risk of the 10-minute timeout. We've all experienced where in lower environments we have an integration call that takes 2 seconds, and then once we submit this up to prod and deploy it, it's taking 12 minutes and the chain is breaking. So we want to be very careful of what we're chaining through, especially when we have these potentially smart services that may take a really long time inside the process. So the recommendation here is to move all of your expensive, unattended work outside of the chain. Use an asynchronous start process, an asynchronous subprocess for all the heavy lifting. You want to use activity chaining only for the lightweight, fast path nodes that the user must have. All right, so this is a very common pattern that I'm sure all of you guys have seen, where we have a user input task, then maybe a processing node, an XOR gateway that's going to check, hey, did we process all the items in the list? And then if not, let's loop back. And if we're activity chaining through all of these, we run the risk of hitting that 50 node limit very quickly. Under normal load, when we only have a small number of iterations to run through, we probably aren't going to be hitting the limit. But under unexpected load or large batch sizes, we very quickly and unexpectedly and unpredictably can hit that 50 node limit and the activity chain would break. The recommendation here is, especially when you're creating this gateway loop pattern, is to be very careful with your overall design and be very mindful with the nodes that you are activity chaining through. You want to merge the like nodes where you can, like for the example, the write to multiple record nodes, for example, into a single node. Or again, like if you have any looping that you need to do, try to have that exist in the script task itself instead of using the process model nodes to create that loop for you. All right, now let's start breaking some things, the fun part of the entire presentation. Sorry, Casey.
It's okay.
So we're going to start the live stress test demo. We actually have a recording of this, and we'll kind of walk through that. So first, we're going to go through a working example. Let's all check our assumptions here. What does it actually look like to activity chain through 50 unattended nodes? And let's just make sure that works. And then we're going to go through a series of broken process models and then talk through how to fix them, why they're broken, and to go through some quick tips and tricks there. All right, so we have a recording of this all working. We didn't want to run the risk of the Wi-Fi not working for us. So here we go. So the first example that we're going to go through is our happy
Do not
path.
have 50 write nodes all next to each other.
Yeah, don't do this, please. It's a crude example, but very straightforward. You can easily see here, we have a user input task at the start of this process, and then we have 50 beautiful write-to-record unattended nodes, all kind of counted. I know the font's a little small, but trust me, there's 50 here. And then it activity chains into a second user input task here. So if activity chaining is working, which it should, again, it's the 50 node max between the two attended tasks, then we should be able to successfully activity chain through to our second user input task. So what we're going to see here is I'm going to click this related action. That brings me to the first user input task in the process model. That's the dialog box that we're looking at right now. And by clicking submit, that's going to fire off the form, and we're going to start activity chaining through those 50 nodes. And then we are going to then land on our success confirmation page, which we can see here. Looks very similar to the landing page, but we just want to show you that that's what you're going to be looking for, the big success in green, to indicate that we've successfully activity chained to that second user input task. All right, so what happens when we add just one more unattended node, one more beautiful write-to-record node between our two attended tasks? Well, we all know it's going to break, right? But what in practice does that actually look like, and how do we actually troubleshoot this? So we're going to fire this off. I'm going to initiate this process model. We're going to attempt to get to that second user input task, but unfortunately, the chain breaks, and we're navigated right to our home screen, and we're not navigated to that second user input task. So what if we're in production and we're told, hey, I need a root cause analysis people are saying, hey, I'm not making it to my second user input task. I'm not making it to that confirmation page or the third step in the wizard. And you need to go in, create a root cause analysis, and prove to them that that activity chain did break. Well, in order to do that, what we can do is go to the logs and grab the activity chain error log. So apologies, let me go back 2 seconds. What we did right here was, I'm going to pause that real quick. We found the process instance that we just ran. We saw that it ran on engine number 0, and now we're going to go to our system logs and navigate to the process execution log for engine 0. So I opened up another tab. I navigated to our logs. This particular environment has 3 process execution engines, 0, 1, and 2. You can identify which engine this process execution log is associated with by looking at that middle digit here. So this is engine 0, and this is a really old environment. I think it's over 10 years. So we already have some retired logs here that you can see. So the first process execution log for each of these engines is the one that's retired. The second one is active. So we're going to open up the active prosecution log for engine 0, and we're going to scroll all the way down to the most recent logs, and we will see that we have an error for activity chaining. It's very clear, and I know it's at the very bottom, but you will be able to see that there's a tag that says activity chaining. So as a developer that's debugging this, it's very quick to go find, hey, I know what engine this process instance ran on. I know we're not being successfully navigated to that second, third activity user input tasks, Let's just navigate to the logs, see if we're gonna, see if we find an activity chaining error, and then definitively then maybe copy that error, put that into my root cause analysis report to prove that this actually did in fact happen. All right, here we have another broken process, and it looks like it'll work, right? We have 2 user input tasks and then a subprocess, and there's only 50 nodes in that subprocess, and 50 is the max, like we just saw in the first example. But actually, this chain breaks. We aren't successfully passed to and navigated to that second user input task, and the reason for that is because although there are 50 nodes in this subprocess, the parent subprocess node itself counts as well. So it's 50 nodes in the subprocess, which we'll take a look at, just check our assumptions there. So the 48 write-to-record nodes, and then our start and end node, which is 50. And then we have, of course, the subprocess node itself and the parent process, which is 51. So actually we have 51 unattended nodes between our attended tasks, and that's why the chain is breaking. So in this example, we're going to just quickly fix it. Just check our assumption here. If we actually delete one of those write-to-record nodes and then save, will we be able to successfully navigate from our first user input task to the second one now that there are only 49 nodes in that subprocess? We're going to click submit because we just adjusted by 1. And we could see success. We were navigated right to our second user input task. So key takeaway there is that, again, when we're activity chaining through subprocesses, all the nodes in the subprocess count, including the start and the end node, and then the subprocess node itself and the parent process counts towards that 50 node budget. Okay, what about this one? This one's sneaky. This looks exactly like our first example, which worked great. But the only difference is that we have a start process form instead of a user input task. So instead of activity chaining into user input task, the user is going to interact with the start form to then initiate that process. And let's try activity chaining into that second user input task here again. And nope, that does not work. And when you think about it, when we have start process forms, when a user interacts with a start process form, that process does not actually initiate until they submit the form. And because the process does not actually initiate until they start the form, we then count that start process node as an unattended node between our attended tasks. So what we have here actually is 50 unattended nodes with all of our write-to-record nodes, and then an additional start node, an additional unattended node here, so technically we have 51, and that's why our chain is breaking. So again, if we got rid of that 50th write to record node, then the chain would be successful. We would be navigated to our second user input task. All right, we talked a little bit about the second mode of failure for activity chaining, which is if you hit that 10-minute limit. We actually kicked off this process before the demo, so you don't have to wait and watch this run, which would be incredibly boring. And what we wanted to show here, well, just to give you a review of what this process model is that we have our two lovely user input tasks that we've seen time and time again, and then between them we have two API calls that take about 5 minutes each to load, which is in total 10 minutes, and therefore we're going to breach our 10-minute timeout limit. And what we wanted to show here is that you can navigate to the logs and then also find a very similar activity chaining error here as well. So if you have if you've heard that your process models, your user isn't being navigated to maybe their second user input task, and that's because maybe the activities between those are taking a very long time, you can also find that specific activity chaining error in the logs the same way we found the first one. You go from monitoring, find the engine, find the associated process execution log, and then boom, you're on your way to find that particular activity chaining error in the process execution logs, and then you can write up your report or provide that to your senior developer to attest that the chain is being broken because it's exceeding the limit. And then lastly, the last example that we wanted to walk through and show you guys is some updated functionality with the ABang start process. And so here we have a process model that is activity chained all the way through. It's calling a smart service that copies a document, which is just a PDF. So to generate a new document, it's just copying an existing PDF. And then we are then passing that PDF, that new document, into the interface, into this display document viewer here. So what we're about to experience is we're clicking this Generate PDF button, but our document is no longer displaying. Recently, Appian updated a handful of releases ago the ABang start process functionality, introducing a new parameter called is-synchronous. So beforehand, we didn't have this, and the kind of design was if you had a process model where you needed to activity chain up to a certain point to get a value at a certain point, we would ensure that all the nodes up to that certain point are activity chained, and then we would feed that back up to the process model. And we didn't have, to that interface. And we didn't have this additional parameter called is-synchronous. But now, even though that the process model is activity chained all the way through, because I didn't set my is-synchronous to true, we're not passing that new document ID back up to the interface. So with the introduction of is-synchronous, we do need to set this parameter to true in order to ensure that the interface will wait for the process to complete in order to then feed in order to execute the on success ABang saves. And then we're just going to see here, we're going to set this to true, and then we're going to click save. And then we're going to navigate back and then generate that PDF. Something else to note as well is that for on success, the underlying process model, does not have to be activity chained all the way through as well. As long as the is-synchronous parameter is checked to true, the process model itself doesn't have to be activity chained through. The interface automatically will know to wait for that process model to complete. All right, so those are all the lovely examples. Oops, I exited out of the process, not the process model, the PowerPoint, oh my gosh. All right, so let's close the loop here. There are 4 things that we set out to cover. When you're evaluating the engine impact, chain nodes get maximum priority. It's a very powerful tool that potentially, if used incorrectly, may starve background work at scale. So using activity chaining, we must design very carefully. If we are going to be using activity chaining to architect complex subprocesses, we want to ensure that we've configured all of our nodes within the process model correctly, ensuring that the process models are synchronous, that we are mindful of where our attended nodes are, that we have enabled the appropriate settings to ensure that cross-process chaining is successful, and that we're very mindful of the 50-node budget when we're designing our potentially very long process models. If we want to ensure that users see refreshed data when they are interacting with like a user interface or like a related action, and then inputted data and then submitted that form, we want to ensure that we've activity chained all the way up to that last write to record node or of whatever record has the data that they want to see refreshed. We want to ensure that the user doesn't see any stale data. Oh.
There's a party next door.
That's where we're all going next.
Yeah, we'll see you there.
And then, of course, when we're troubleshooting broken chains, we want to keep in mind the 50-node limit, the 2 failure modes, the 50-node limit, as well as the 10-minute timeout, and to be very careful when we're activity chaining through gateways, as well as activity chaining through MNI. All right. So last thoughts here that we want to depart with here are that activity chaining is a precision tool, not a default setting. When chaining deliberately, when you understand the engine costs, the node counts, the right ordering implication, it's a very powerful tool. It gives you control over the execution sequencing in ways that most platforms don't even expose to developers. But when chaining carelessly without thinking about what's inside, it can cause some really confusing production errors. The chain keeps us together when you use it correctly. Thank you.